So folks, I want to do a second example now of matrix multiplication. And we're going to use the same two matrices as before, but now we're going to compute the product B times A, matrix B times matrix A. And there's not a whole lot different here, but what I'd like to do is I'd like to show you another way to set up the problem. So one way we could do this is if we took our matrix B, and give yourself some room up above here. I'm going to put matrix B here, so we've got 3, 1, minus 2, 0, and 2. So that was our matrix B. And then we're going to multiply this to our matrix A. And what I'm going to do, just to help with the bookkeeping procedure of this, is I'm going to put matrix A up here, up above it. And the reason why someone might want to do this, it takes up more room. It's a little bit clunky. But the reason why somebody might want to do this is it helps them keep track of the rows and columns of the product matrix. So what we can see here is that when we multiply matrix B to matrix A, we said we multiply for this position right here, and let's label that as the 1, 1 position. And for that 1, 1 position, you're going to take row 1 of B, and you're going to do that multiplication that we discussed in the last video to column 1 of A. And the first thing I want to point out is that that actually is feasible. That dot product is actually feasible to take the row 1 of B and the column 1 of A because of their lengths. That is, if I take 3, that first entry, we'd have 3, and we'd multiply it to the first entry in the row of A, so that's 3 times 1, plus, and then we'd take this second one here, that's an entry of B, and we would multiply it to this second entry in the column here. And what I mean when I say that's feasible is we have this, the length of the row of B is the same as the length of the column of A, for lack of a better term. So we can actually do that computation. That's what we mean when we say the matrix multiplication is defined. So this would be the value 3 here. And what we can actually see is because I've outlaid it this way, you can actually see the size of this new matrix as you do this, because for this entry right here, you would take this row times this column, and then you'd have another entry right here, which would be this column and this row. And you see that the result of this multiplication visually appears to be a 3 by 3, if you can see what I mean by looking where the row and the columns would be multiplied together. So let's just do one more. Let's go ahead and just do this position right here. Well, this is the 2, 3 position. So I'm going to take row 2 of B, and I'm going to do that row column multiplication with column 3 of A. And so I'm taking, let's kind of clean up my marks here. Let's see what we can do. We're going to take negative 1, and we're going to multiply it to 3, and then we're going to take negative 2, and we're going to multiply it to 2. And if we simplify that, let's see here, that's negative 3 minus 4. When I do that, I get minus 7. And so that's that entry right there. So go ahead and pause the video and try to perform the rest of these calculations. Let me know if you have any questions, and I'll fill them in a moment. Okay, so if you're feeling good with this, go ahead and move on, but just real quick, I'll give you one more. Let's say for this entry right here, this is the 3, 1 entry of the matrix, and so we took the row 3 of matrix B, and we multiplied that to column 1, 3, 1. We multiplied that to column 1 of A, and when I did that multiplication, I did 0 times 1 and 2 times 0, and I summed those together, and that's where I got that 0. So hopefully that explains that multiplication. So let's bring in a new matrix, and we're not actually going to give any values for that. Let's C, let me scoot this up. Let C equal a 1 by 3 matrix. And I want to talk about whether or not we can multiply this to matrix A. So let's first go ahead and try to compute matrix A times matrix C. So let's just say that, compute AC, and all of these sort of come with the implicit extra direction if you can. And let's go ahead and try to set that up. And I didn't tell you what matrix C was, but let's just go ahead and set it up in that diagram the way we did before. So if I take matrix C, it's a 1 by 3, and matrix A was a 2 by 3. So here's matrix A. It's got this entry, this entry, this entry. These are the 6 entries of matrix A, and we would try to multiply this by, so there's A, and we're going to try to multiply this by C, which is a 1 by 3 matrix, 1 row, 3 columns. And if we set this up, the product that we would try to calculate, well, let's just see how we do this. You would say take this row times this column. But look, this row has length 3, this column has length 1. It's impossible to multiply those two together. So this can't be done. But let's go ahead and look at what would occur if we tried to compute C times A. So again, I'm just kind of doing this diagram picture, which I think is a little bit helpful. And here we have C. We've got 1, 2, 3, 1, 2, 3. And we notice again that we can't do this multiplication. Notice that we would take, to find an entry, we'd have to be taking a row times a column, and those don't agree in length. So this, again, can't be done. Let's go ahead and just for fun, let's go ahead and set up B times C, matrix B times matrix C. Well, let's see here. Matrix B was a 3 by 2, so if we set that up, we'd have 1, 2, 3, 4, 5, 6. There's its 3 by 2. And if we set up matrix C, we would have 1, 2, 3. And let's look at what we'd have here. Again, we can't do that multiplication. And then last, let's try matrix C times matrix B. So matrix C is a 1, 2, 3, and we're going to multiply this to matrix B. So this was C here, and we're going to multiply this to matrix B. And notice at long last, we actually get something that lines up. And so we would see that the resulting matrix, this would be the product, would have what dimensions? Well, we could multiply this row times this column for that entry there, and this row times that column for that entry there. So the product would be a 1 by 2 matrix. Let's see if there's a way we could sort of ascertain that just by looking at the dimensions of the matrices without drawing this picture. So let's see here. Matrix C, we said, was a 1 by 3 matrix, and matrix B was a 3 by 1 matrix. And we said that this multiplication was permitted. And the reason why is because the length of the rows, so C has 1 row, but it has 3 columns, so it has a length of 3. The length of the row matches the length of the column, because B's columns have 3 entries in them. And so that multiplication works. So whenever you multiply two matrices together, if you have C times B and these interior dimensions align, this means that multiplication is possible. And notice that we said that multiplication was possible, and the result by just laying out the picture would have been a 1 by 2 matrix, and we can actually see the dimensions of that new matrix in the expression there. So that would be a 1 by 2 matrix is what you get when you do that multiplication. So hopefully this clarifies the issue of dimensions for multiplication of matrices. And one thing I do challenge you to do is go back to where we actually define matrix multiplication and see where in the definition it actually required the rows of the first matrix to be, the columns of the first matrix to be equivalent to the rows of the second matrix. It's actually in the definition there, and that's the only way multiplication would actually be well defined. Folks, that's all I've got for you for this video, and we will pick up with matrices in class. Thank you very much.